What's up, guys? So today we're going to be talking about coordinate geometry. Coordinate geometry is super easy, honestly. Basically, it's taking everything you know and it's just showing you another way to apply it. So there's really not a lot that's going into the mechanics of this, but I am going to be showing you different ways to apply it. So first off, let's jump in. We're talking about distance formula. So when we're talking about distance formula, this is saying the distance is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. And basically, this comes from Pythagorean theorem. Now, I'll show you guys how to derive this just because it helps you guys figure things out just a little bit better. But basically, what's happening here is we're saying, hey, if I had these 2 points here, we'll call this point 1 and we'll call this point 2. What if instead of finding the distance this way, I said what's super easy is I can tell you how much left and right I traveled, and I can tell you how much up and down I traveled. I know that this is 4. I know that this is 3, so we can easily figure this out by saying, okay, so what's the hypotenuse? By using Pythagorean theorem. X squared plus y squared equals z squared. Or in this case, 3 squared plus 4 squared equals distance squared. Now, all this is doing here is it's saying, how do you find this length? Let's say that this x here is 7, and this x here is 11. How do you figure out how far it moved? And the way we do that is with your difference. What's the difference between your endpoint and your starting point? That's how you find your distance, and you just find that by using subtraction. So the way we find this distance here is just x2, my ending point, minus x1, my starting point. And that's exactly what we're doing here. So if you notice, this is just distance equals square root of x squared, x1 minus x2, how much I moved my x, squared, plus y1 minus y2, how much I moved my y, squared. So that's basically how we're using Pythagorean theorem. Again, just make sure you memorize it and just plug it in. That's the derivation. It could come in handy, but honestly, it's not the end of the world. It's pretty easy to memorize distance formula, so I would suggest just memorizing it, but it's nice to know. Now, again, like I said, all you're doing really with coordinate geometry is you're finding new ways to apply distance formula. So one of the most common practice problems is saying, hey, decide if these 3 points are collinear or not. Now, maybe you can graph it on a nice dotted line and like draw a line through it, but if you're anything like me, and as you can tell, I stink at drawing. So because of that, it might not be perfect. So instead, one way that you could always decide collinear, if you remember, is we said take AB, take BC, and if AB plus BC is equal to AC, that means they're all collinear, because if there's this extended portion here, if I have to move up, so let's say this is 3, and this is 4, there's no way this would work out because you're taking a detour. But if it was all on the same line, like this, 3, 3, 6, then the only way that the two lengths would be the same is if you were kind of going in this straight line. So that was one of our things we learned from, I think it was like chapter 1, where if 3 lines it was chapter 2, excuse me. If 3 points are collinear, then AB plus BC has to equal AC. Segment addition, right? Part plus part equals whole. So basically, that's the idea that you're using. You're applying segment addition, and then you're using that, and you're just testing it here. So let's decide if they're collinear or not. So let's find distance of A and B. Whoops, I'm going to do this in capitals. So this is one way that you can organize it. You have distance, and if you have multiple distances, all you're going to do is you're just going to say, okay, let's use subscripts. That's these little letters here. So distance of AB is different than distance of BC, and which is different from distance of AC. And again, the 2 points, those are just your endpoints. This is notation. You don't need to do this. This is just one way that I find it easier. Some people like saying, oh, the distance from A to B will be called X. Distance from C to D is called Y. To me, that's more confusing, but however you want to do it. This is one method. This is also really commonly used in chemistry and physics as well, so I would suggest getting used to subscripts. So distance from A to B is equal to square root of 3 minus 5 squared plus 4 minus 8 squared. Square root of 5 minus 6 squared plus 8 minus 9 squared is equal to the square root of 3 minus 6 squared plus 4 minus 9 squared. Okay, so then now we're just going to solve. So we have distance from A to B is equal to the square root of 3 minus 5 is 2, 2 squared is 4, 4 plus 4 squared is 16, so 4 plus 16 is 18, square root of 18. Distance from B to C, this is going to be equal to the square root of 1 plus 1, so that's the square root of 2. And then distance from A to C is going to be equal to 3 minus 6, that's 3. 3 squared is 9, plus 4 minus 9, that's 5. 5 squared is 25. 9 and 25 is 34. Okay, now, if you remember, when you're adding square roots, you cannot just add from... Okay, sorry. I paused really quickly because I was like, I swear I'm taking crazy pills. This shouldn't be square root of 18, and I was correct. So we're going to write this out because we're not going to get called out by any specific person about having incorrect answers on my answer key. So this is going to be 4 plus 4 minus 8 is 4. 4 squared is 16. 4 plus 16 isn't 18. It's actually 20. My bad on that, guys, which is why you should be writing it out and not trying to rush through things. Okay. Now from here, you're not allowed to just add inside of your square root. So what you're going to have to do is you're going to have to plug this into a calculator, or you're going to have to simplify. So then let's plug this into our calculator and then see if it works out. Okay, now if you plugged it into your calculators, you should have got 5.83 and 5.88. Unfortunately, while really close, they're not the same. So this is not collinear. So that's how we're using one of your rules from chapter 2 to kind of figure this out. Again, this is a super standard problem using distance formula to decide whether things are collinear or not. Really not the most effective way. There's a more effective way I'll show you guys in the slopes, but this is just one way that you could do it. Again, this is just a standard problem. Next is identify the shape. When you're doing these identify the shape problems, what it's giving you is it's giving you 3 different points. Now, obviously 3 points are going to form a triangle. So the question is, what type of triangle is this? Is this an equilateral triangle? Is this an isosceles triangle? So that's your goal. Just like before, if I gave you something like this, and I said, what type of triangle is this? You would have had to tell me this is an equilateral triangle. The reason you know it's equilateral is because it's obviously isosceles because these two are congruent. If my legs are congruent, then my angles are congruent. And if this is 60, that means there's 120 degrees to split here, and that means it's 60, 60. Oh, look, it's equiangular, which means it's equilateral. So basically, you're doing the same thing, but instead of giving you information that way, I'm just giving you 3 dots, and you're going to figure it out that way using distance formula. I'm not going to show you guys how to do this because doing distance formula does take a little bit of time, and I want to keep these videos short. All right, lastly, when we have something like this, it says find the possible coordinate. The distance between 3, 5 and -1, x is 4. Find the value of x. So what you're going to do here is you're just going to plug it into distance formula. 4 equals the square root of 3 minus -1 squared plus 5 minus x squared. And then you're just going to solve. So then we're going to get 16 equals 4 squared is 16 plus 5 minus x squared, and we solve. 0 equals parentheses 5 minus x squared. We square root both sides, so we're left with 0 equals 5 minus x, so that means x equals 5. Works out nicely. Okay, that's it. When you're solving, all you do is you just plug it in and solve for whatever variable is remaining, just like you would anything else. If you were given a lateral area, for example, and you're saying, oh, my lateral area is perimeter times by height, and you're given lateral area and perimeter, you can use that to find height. It's the same basic concept. Okay, now that we have that done, next we're going to talk about the equation for a circle. Now, when you're doing Algebra 1, you guys learned how to graph parabolas, you learned how to graph lines, and there's another one that you can graph, and you can graph circles. Now, basically, if you notice, this is super similar to your distance formula. I could explain why, but all I'm going to say is based on the distance from the center, that's how you find your radius, which is why it makes sense that you have a radius formula that looks real similar to your distance formula. As always, just like when you're doing slope-intercept form or parabolas, you get specific information. So the pieces of information you need to graph a circle is your radius, which is r, and your h and your k. Your h and your k is going to be the center. So again, these are the things that you need in order to graph, and let me show you how this works. Oops, excuse me, I'm giving you a difficult problem to start with. I didn't even give you an example. So if I give you something like this, 16 equals x plus 3 squared plus y minus 2 squared, this is going to be the equation that you're given, and I'm going to ask you to graph it. So what you're going to say is your radius is equal to radius squared equals 16. So the way you find it is your radius equals 4. Then your h comma k is going to be negative 3 comma 2. And the reason why you know it's negative 3 comma 2 is because whatever is inside your parentheses should be swapped, because it should be x minus. In this case, you have x plus, so you're going to swap it. So this is your center. Now let's just graph that out. So we're going to say negative 3, 1, 2, 3, comma 2, 1, 2. That's this point right over here. And your radius is 4. So all you're going to do is you're going to count 4 left, right, up, down. So you're going to go 1, 2, 3, 4. Yikes. 1, 2, 3, 4. 4 points up. 1, 2, 1, 2, 3, 4 down. And 1, 2, 3, 4 to the left. You do generally want to draw it a little nicer than that, but hey, look, it looks like a little happy face. Yeah. All right. But basically, that's the general idea. You put your center, then you go 4 up, 4 left, 4 right, 4 down. Sorry, I thought I had an example on it, but I guess I don't. Next, when you're writing the equation of a circle with a center at this point and has this point and has the point negative 1 comma 3, this is hiding the fact that I'm giving you what the radius is. You know where your center is, so it's going to be radius squared equals parentheses x minus 2 squared plus y minus 5 squared. This is how you find your center. Now you need to find your radius. Now the way you find your radius is you know that the distance, you have your center here and you have this point here. This distance is your radius. So all you need to do is you find the distance from your center to the point that's on your line. So you're going to say radius equals square root of 2 minus negative 1 squared plus 5 minus 3 squared. So that's radius equals square root of 3 squared plus 2 squared, equals r. So your radius equals the square root of 9 plus 4, which is 13. So your radius is equal to square root of 13. So your equation will be 13 equals x minus 2 parentheses squared, so on and so forth. Be careful when you're using equations of circles. Whatever your number is at the end, that is not your radius. That's the radius squared. Okay, lastly, we have something like this. It says a circle has a diameter AB, yada, yada, yada. Now, one thing that you know about the diameter is the diameter goes through the circle, or goes through the center. And if this is r, this is your other r. So basically, if you have 2 points like this, the way you find your center is you just take the point that's in the middle of your 2 points, your endpoints of your diameter. That's another way that I can hide information. Again, there are a lot of ways that I can hide information, but these are the most common. I'm asking you to write an equation of a line where I don't give you the radius because I give you a distance, or I can hide the fact that your diameter passes through your center. These, again, are the most common ways. There are other ways, but these are the most common. Okay. If you have any questions, as always, let me know. I know that this is a little bit up in the air and flowy, but I'm trusting that you guys are relatively good enough that if I just give kind of vague examples like this, you should be able to get the main ideas. And again, the problem is there's just so many different examples I can throw at you, but these are the most common. Okay. As always, let me know if you have any questions, and I'll see you guys later.